Today we're beginning a new section about boost the performance of our machine learning pipelines, specifically the machine learning pipeline that we used in the last section to perform the sentiment analysis task on the movie review data. So I'm going to talk about how we can improve the performance of our models with common NLP techniques like n-grams and whitelisting words and other techniques that can help you diagnose what's happening in your pipeline and also increase its accuracy. In this section, we're going to take a look at number 1, deep diving into raw tokens from movie reviews. Number 2, I'm going to show you how we can use regular expressions and string functions to do advanced cleaning of Python word tokens. Number 3, we're going to cover what is n-grams and how we can create n-gram features using Scikit-learn. Number 4, we talk about how we can experiment with advanced Scikit-learn models and compare them to find the best model for the current task. In the last video of this section, we're going to build a voting model with Scikit-learn. What that means is we're going to combine the outputs of multiple models and we'll allow them to vote on what's the right answer. So in this video, we're going to start this section by deep diving into the raw tokens of the movie reviews. In this video, we're going to take a look at two different things. So number 1, why do we look at raw data, and why does looking at raw data help us create better features? And number 2, whitelisting words relating to sentiment. So why would we look at raw data, and why does that help? I think a lot of machine learning and natural language processing literature or tutorials out there kind of present machine learning as a big black box where you have libraries like TensorFlow or Scikit-learn or Keras, and the tutorials simply say, oh, you can do this by chaining these function calls, and that's about it. It's very hard for you to learn how to generalize from that data or generalize from that course. So here I want to kind of walk through together an example of one of the movie reviews just to get a flavor of how I think about the raw data. And the reason why this is important is because we want to use and understand the raw data in a sense where we can then engineer good features or select good pre-processing procedures for our natural language processing pipeline. So let's go take a look at one of the movie reviews and see what we can recover. So this is one of the examples within the positive category. The first thing that we notice is if we only split this review, we actually will then get a lot of punctuation. So because of how this is already tokenized into words and punctuation, we can probably, instead of using word tokenized from NLTK, we can probably just use splits and then take out anything that doesn't contain A to Z as characters or numbers so that we conveniently take away the punctuation. The other thing we notice is because of the expressivity of the language and also the fact that we're trying to parse sentiment, sometimes removing stop words like no is actually detrimental to the prediction because it removes information. So for example, here if we remove no, then the whole phrase becomes wastes time, and that obviously has a very different meaning than wastes no time. The other thing that we notice is if we chunk this or tokenize this individual words, there's no way for us to understand whether wastes is a positive or a negative modifier because we don't know that wastes is coming before no time, right? So that's another thing we notice. Scrolling down, we can also notice that when people talk about movies, sometimes they use parentheses, and a lot of the information inside parentheses are merely names or quotes, and they are less relevant to things that are actually indicative of the sentiment of the text. So another strategy might be, after removing auto stop words, we also remove everything that's within the parentheses before removing the punctuation itself and then taking that into a vectorizer. So all of these are examples of what you would notice in terms of, okay, if I were to do it as a person, what kind of information would inform me whether this is a positive or negative movie review, right? And you're trying to replicate that in your machine learning pipeline to help the machine learning algorithm or the natural language processing algorithm to do better, because instead of forcing it to learn this information by hand, you've already seen that something like, okay, you know what, inside parentheses are less relevant things, so just remove it so the model doesn't need to deal with it, and it doesn't need to learn that the fact all words between parentheses are less informative or less relevant to the sentiment of the movie review than normal. So I also want to talk about whitelisting. So when we looked at the review just now, when we looked at the first one, we say that if we remove words like no or not, although these are stop words which appear a lot in English, removing these words are detrimental to sentiment analysis because it removes certain, it's a big indicator, right? Because words like no and not negates whatever that comes after this word, and when you're trying to interpret the sentimentality or the polarity of the particular movie review, the fact that something like happy is negated by not is very important. So we shouldn't remove these stop words within the stop word list. So what we're trying to do here now is we first do sentiment analysis stop words, and we set this equal to nltk.corpus.stopwords.words. So we're retrieving the English stop words from the NLTK package, and then by hand we take out so what we do is simply to print out all the stop words that we retrieve here, and then we pick out all the ones by hand which might invert a sentence's meaning. So you have things like what, but, if, and also things like no, nor, not, only, own. So I've taken all these things out, and this is one of the strategies where we try to manually influence what goes into the model. So then from here on, all we need to do is to create a new list of stop words by taking out the whitelisted words using a list comprehension, and then suddenly we have a much better way to make sure that all the information is now there. So we've just learned, number one, why looking at the raw data can help us create better features. Number two, whitelisting words related to sentiments.